Okay, okay. In the last video, we defined the molar concentration definitions, and we did one numerical problem. So in this video also, we will do something similar, and we will do some problems, and then we will go to the water properties. Okay. So now let's take one example, molarity. Okay. Previously, we find the molarity, parts per million, percentage weight by volume, etc. Now let's do one problem for the molarity. Okay. Okay. So molarity. So that is molarity. We know we have already discussed mole per liter, right? It is denoted by capital M. Okay, guys. So now let's see. Describe how to prepare 2 liter of 0.1 m NaOH. So we have to make 2 liter of 0.15 molarity NaOH. So we have to make that. Okay. So this much M. So first of all, you should understand that 0.15 m, capital M, 0.15 molar means that 0.15 mole in 1 liter. So, so you need the 0.15 mole to to make 1 liter solution, but you have to make how much? 2 liter of the solution. You have to make 2 liter of the solution. That's why first of all, how many moles you need? That's why 0. So 2 liter of 0.15 m is equals to 0.15 mole by 1 liter times how many liters you have to make? 2 liter is equals to how many moles you need? 0.3 mole. So we need the 0.3 mole, right? So we need the 0.3 mole. So we need the 0.3 mole. So you see 0.3 mole of NaOH, we will need the 0.3 mole of NaOH. So, but the sodium hydroxide, let's convert that into the gram. So 0.3 mole of NaOH, sodium hydroxide, is equals to, how do you convert a mole into the gram? You just multiply the molar mass, right? 0.3 mole times, what is the sodium hydroxide mass? 40. 40, because the sodium plus oxygen plus hydrogen, right? So that's why this is a 40 gram, right? 40 gram per mole. So mole cancels. That's why this is equals to about 12 0 gram NaOH. So you need the sodium hydroxide 12 gram. So then now mix 12 gram, 12.0 gram of NaOH in how many liters? 2 liters. 2 liters, and then it is 0.15 m of NaOH. So that 2 liter is 0.15. It's smaller is that. So now let's take another example. So that another example is if 5 gram of NaCl is added to water and made 2 liter solution, what is the molarity of NaCl? So right, so 5 gram of sodium chloride is added to 2 liters, and what is the molarity of NaCl? Capital M. So first of all, molarity is equals to mole per liter, right? That's why convert a gram into the mole, and a liter is liter here. Okay, so that's why now gram, how many grams? So the 5 gram of NaCl is equals to 5. Let's convert a gram into the mole. 5 gram divided by, so sodium chloride mass is 58.44, right? 58.44 gram per mole, right? So that's why you have um, gram cancels, and that is equals to, it's given here somewhere, 0.08 0.56 mole. This much mole of NaCl, and you are adding that to how much liter? 2 liter, right? Because I already in the previous slide also I point out that the sodium chloride, if you mix that, then you are not increasing the volume, because sodium and chlorine sit on the open vacant position of the water, two waters molecules in between, so there is no change in the volume. That's why we are not changing the volume. So how many moles? 0.0856 mole are present in how many liters? 2 liters, right? 2.00 liters is equals to 0.0428 mole per liter. That is equals to 0.0428 molarity. So that molar 0.0428 molar solution, that will be. There is another example. What is the molarity of the solution prepared by dissolving this much gram into this much gram? Okay, right. So this much gram into this much gram, but we have to convert into the molarity. So similarly, now we need the density here, right? We need the density here, because otherwise you don't need the um, volume. So first of all, 32 gram of CaCl2. So 32 gram of CaCl2 in 271 gram of water, right? 32 gram of calcium chloride in 271 gram of water. 32, now convert the 32 gram of CaCl2 into the mole, and it is given. So mole of calcium chloride is equals to 0.288, right? Because you see, 32 gram CaCl2 equal to 32 gram times 1 mole by 110.9 gram per mole. So that is we converted gram of calcium chloride into mole. So that is the mole. Okay, so calcium chloride also can dissolve, right? So that's why you are not even changing the volume. So your milliliter is 271 gram of water, right? But what is the density of water? Now convert this gram into liter. 271 gram divided by what is the density? 1 gram per ml, right? So convert that ml into the liter is equals to 10 to the power so you 10 to the power 3 ml in 1 liter, right? So that's why you converted that gram into the liter. So how much is that now? So the gram cancels. That much. Okay, let me first of all convert that sorry, convert that gram into the milliliter. Okay, 271 gram divided by 1 gram per ml, right? So now this is 271 ml. That's 271 ml. And now let's convert a ml into the liter. 271 ml divided by 10 to the power 3 ml, right, in liter. So that's why 271 by 10 to the power 3 liter. So this is the liter of the solvents. So the molarity is equal to, that's why the molarity is equals to 0.288 mole, 0.288 mole divided by 271, right, times 10 to the power minus 3. So 10 to the power minus 3 liter, right? So that is equals to 1.0627 mole per liter. That equals to 1.0627 molar. That is the molar solution. So we have done this, okay? So now let's go further. So we have this one example, same thing, molarity. We have bunch of these example, okay guys, similar, exactly same. If the concentration of NaCl in blood serum is approximately this molar, what volume of sealer contains 2 gram of NaCl? It's the same thing, right? So now you are given the molar. So let's see that 2 gram. See, 2 gram of NaCl. What is the volume? First of all, convert a gram into the mole, this much mole. So the molarity mole by NaCl by liter of NaCl, right? So the molarity is given 0.14, right? 0.14. And the liter of NaCl is unknown. Mole of NaCl is given 0.034. So that's why M is equals to mole of NaCl by liter of blood, right? So, and you can crisscross, and a liter of blood will be equals to mole of NaCl divided by molarity, right? What is the mole of NaCl? 0.034, right? Divided by molarity is 0.14. So see, mole by molarity will give you the liter volume, right? So that is equals to 0.24 liter. So that is the 0.24 liter. So now, so yes. So now another type of question is, this much ml of stock NaOH density is this is diluted and prepared a solution of 2 liter. What will be the concentration of this diluted one? That is another example. This is a good example. It is useful in your laboratory also. Now let's say this example. Okay, so 55 ml, 55 ml of NaOH, but the NaOH, sodium hydroxide, can have different density. Okay, guys. So, but what the density of the sodium hydroxide? 2.130, right? This is the density of sodium hydroxide, gram per ml. 55 milliliter, this gram per ml is diluted. That is diluted. Now this is the ml. Now look at that. Already it has the milliliter. That's why if you add that volume, your solution volume will increase. It's not like salt dissolve in water. So in this case, volume will be increasing. Okay. So now the solution of solution of 2 liter. Oh, okay, no problem. We have to make the solution. It means that you don't worry about that, right? So what you will do is, first of all, you calculate the mole, and you will convert that mole into the gram, and you put that gram on your beaker, right? So the 55 ml, you take that much volume, put that volume in the beaker, and fill the water up to the 2 liter. That's the way. Okay. So the molarity is equals to, now that's why in this case the molarity, first of all, molarity is equals to mole of sodium hydroxide by liter of solution. Okay, so mole of hydroxide means what? Gram of NaOH, gram of sodium hydroxide divided by 39.99 gram per mole, right? This is the mole of, and what is the liter of the solution? 2 liter. So, but the gram is not known, right? Gram can be calculated by density times the volume. Okay, so gram can be calculated by density times volume, right? So the density is equals to mass per volume, right? Mass is the gram. Mass is equals to density times the volume. So this is, the gram is not known, but we know the density of sodium hydroxide. We know the volume of sodium hydroxide. That's why this is gram of sodium hydroxide. Now let me take the different color for that. Okay, so it's easy for you to understand. Gram of NaOH. So gram of NaOH is not known, but the gram of NaOH can be found out by density times volume. Density of NaOH times volume of NaOH, that's the gram of NaOH, divided by 39.99 gram divided by 2 liter, and this is the mole, right? So now let's go further. So what is the density of the sodium hydroxide given? Density of the sodium hydroxide is given here. What is the density of sodium hydroxide given? 2.1913, right? 139. So density is 2.139 times volume is given. Volume is how much? 55 milliliter. Convert that into the liter. 55 ml divided by divided by, so 39.99, right? 39.99 gram per mole divided by 2 liter, right? This 2 liter. So this is equals to, convert that milliliter into liter. That's why 2.19139 times 55 times 10 to the minus 3 milliliter into liter divided by 39.9, right, times 2. Yes, what is this? This is your molarity. That is equal to 0.0014709 molar. So that way, if the density is given, convert that into the gram and convert that gram into the mole. That's why indirectly, if you are given volume and the density, then you can convert that volume and the density into the gram. Finally, gram into the mole divided by liter. So this is okay. This is right. So I hope you can calculate if the milliliter of stock solution is given and its density is given. You can write down its a molarity if you get some solution. Okay. So okay, now similar problem now we have here. So how do you prepare? So how do you prepare? Now let's see that here. Let me put that here. Okay. So look at that. If we dilute a solution, the number of moles. So prepare the solution from stock solution. You know that in the laboratory, stock solutions has different concentration, but we have to convert that concentration as our need. So for that, so for that, um, so for that, we prepare the solution from the stock solution. Okay. So that is easy. That is easy. So we have different concentration, and we will convert that concentration into our desire. What is our need? As per our need, we convert that in our concentration. Okay. So now the formula is M1 molarity of 1 V1 is equals to M2 V2. For example, M1 is the molarity of the stock. B1 is the how much volume you need to stock, equals to molarity of your prepared solution and the volume how much you want to make the prepared solution. That's it. So let us take one example and you will understand better from the example. Okay. So very easy. M1 B1 equals to M2 V2, and do that and you will have the it's a solution. Okay. So now let's take the example here. So look at that. How would you prepare 200 ml of 3.5 m aqueous solution of acetic acid if you have a stock solution 6 m acetic acid? So look at that. My stock in my the stock room of the laboratory, I have 6 m acetic acid in the big jar. I don't need 6 m. I need 3.5 molar. But my store has 6 molar. So I have to convert that 6 molar into 3.5 molar. But how much I only want to make? 200 ml. So look at that. So M1 is equals to M1 B1 is equals to M2 V2. M1 is equals to, so let's see. So M1 in the previous case, okay, M1 is equals to, so okay, now let me go to the previous one. Okay. So in the first problem, this is the second problem. We have the two problem here. First problem, M1 is equals to 200, let's say stock, okay, and the V stock is equals to 200 ml. Sorry, not that. Okay, 200 ml is the V1, right? So molarity M1 M of the stock. The same of the stock is equals to 3.5. You can write M1 if you like. So B1 we have to, so M1 means M solution. Okay, M solution. How much? What is the echo solution you want to make? M solution is equals to 3.5, and a V solution is equals to 200 ml. You can write this as a M1 is equals to 3.5, V1 is equals to 200 ml. So M2 is given. So right, M stock is equals to given how much M stock? 6.0. But the how much volume B stock I have to take? I have to take little bit from stock and then I have to add the water and make the solution. V stock I don't know. Let's say that is the M2. Let's say that is the V2. So use the M1 V1 is equals to M2 V2 and find that how much stock solution you need. Okay. So look at that. M1 V1, M1 V1 is equals to M2 V2. This gives me, this implies that M1 is how much? Molarity of first one, 3.5 times V1 is how much? 200, right? Is equals to M2 is how much? 6 times, I don't know V2. That's why 6 V2 is equals to 3.5 times 200, right? V2 is equals to 3.5 times 200 divided by 6. That is equals to 0.12 liter, means 120 ml is equals to 120 ml. So from that big jar, I will take 120 ml. Okay, let me erase that calculation because the calculation is here. I will take 0.12 milliliter, means 120 milliliter. So in that test tube, so that the cylinder, so 120 milliliter, I will take that and I will take another jar or another big jar, big giant cylinder or giant measuring cylinder or the big beaker. That's up to you. Okay, so this mark is, for example, 200 ml. This mark is 200 ml. So from this I will take 120. It will go up to 120 here. This is 120 ml. Mark is here. This I took the 120 ml of the stock solution, and then I will fill the water. I will fill the water, right, and go up to here and say, well done. 200 ml of the 0.35 ml eco solution I can form like that. Okay, so first of all I will calculate how much ml of the stock solution I need, and I will grab that much ml, put on the large cylinder, and then add the remaining part up to the desired volume 200 ml, right? So that's, now another example is if the molarity of the acetonitrile solution is given 10 m, how many ml of this solution will be required to make this much, this blah blah blah. Again, m1 v1 equal to m2 v2, v1 equal that much ml I will need, then I will need 690 ml and fill up to 3 and the 8 water to fill up to 3 liter, done. So so far we have done some problems, and in this video, that's it for today, for this video. And in the next video we'll study about the water is a solvent, water properties, colloids, and etc. Okay, all other suspensions, colloids, these properties of the mixtures we will also study in these type of the mixtures in the next slide or the next videos. And this much the solution concentration calculation for today. And let's take away for today is M1 V1 equal to M2 V2, and we can prepare, we can dilute. How do I make the dilute solution, right? How do I do the dilutions? The previous case, whatever M1 V1 equal to M2 V2, we study the method of dilution. So that's it for today, and let's go. We will wait for the next video, and thank you so much. Bye.